Okay, so here we're going to continue here in Unit 4 with our study of right angle triangles. This time, unlike the Pythagorean theorem, we're going to deal with angles inside of our triangle. So we usually pick an angle to denote our reference angle. So let's say, for example, I pick this angle down here. We're going to call that our reference angle. And in reference to this angle, we can label the three sides of this triangle, okay? So the longest side of the triangle is still the hypotenuse. Okay, but now the side here that is across from the reference angle, we're going to call that the opposite side, right? Because this side is opposite of the reference angle. Okay, and the third side of my triangle is called the adjacent side. Okay, because it's right beside the angle. It's adjacent to the angle, touching the angle. Okay. However, if I took the same triangle, so here I'm going to recreate the triangle again, and this time I made the reference angle up here, then we change the labeling of our triangle. The hypotenuse is still always the hypotenuse because it's the longest side, and the longest side opposite that of the 90-degree angle. But this time, opposite of the reference angle would be over here. Right? It's the side all the way over here, opposite of the reference angle. And then the side that's touching this reference angle, that becomes our adjacent side. Okay, so the opposite and adjacent flip depending on where your reference angle is located. Okay, so the reference angle will always be either the angle that you see up here or down here. It's never the 90-degree angle. Okay, it's not the 90-degree angle. So the reference angle is always one of the other two. Okay, so that gives rise to three ratios that are very important in what we are studying here called trigonometry. Okay. And the ratios help us solve right angle triangles with angles contained within them. So the three ratios are the opposite side divided by the hypotenuse, right? It's just a fraction you can create if you know the opposite and hypotenuse. The second ratio is the adjacent over hypotenuse. And the third ratio is the opposite divided by the adjacent side. Okay? And just to show you how we find these ratios, we can compare the lengths that we see inside of this triangle here for this example A, and I can express the ratios that we have here, the three given here. Okay, so in example A, write a ratio comparing the length of the side opposite to the length of the hypotenuse. Okay, for angle F. So telling us angle F is the reference angle. Okay, and then I'm going to take, I have to identify which side is the opposite side, right? 2 is the opposite side because it is directly opposite of angle F. 5 then becomes the hypotenuse. That's the longest side across from the 90-degree angle. And so I can create my ratio opposite over hypotenuse, this one here, opposite over hypotenuse, by writing 2. Let's write here opposite over hypotenuse. I just use 3 letters to make it short for shorthand. And that ratio is 2 for the opposite divided by 5 for the hypotenuse. And 2 over 5 is equal to 0.4. Okay. We can write another ratio comparing the length of the side adjacent to angle F to the length of the hypotenuse. So the side that's adjacent to angle F, this side here, the side touching the angle, the reference angle, that's 4 meters. Let's label that adjacent. You should always label your triangles, opposite, adjacent, and hypotenuse. Okay, and then we're going to write the ratio of the adjacent side divided by the hypotenuse. So the adjacent side, ADJ, divided by the hypotenuse, HYP, the adjacent side is 4, and the hypotenuse is 5. So 4 over 5, that's 0.8. Now we're going to write a ratio for part C. Write a ratio comparing the length of the opposite side to the adjacent side and express the ratio as a decimal. Okay, so then we're going to write the ratio of the opposite side on top divided by the adjacent side on the bottom, and that's 2/4. And 2/4 is equal to 0.5. Okay. Here's another example. For each triangle below, determine which trigonometry ratio to calculate. Round your answers to 3 decimals. So let's look at triangle A. We have the reference angle at C. Angle C is a reference angle. The 6 centimeters is our hypotenuse, and the 4 centimeters is our opposite side. How do I know? Well, the hypotenuse is always across from the 90-degree angle, and 4 centimeters is all opposite that of angle C. It's all the way across from it. It's not touching the angle, it's all the way on the other side. Okay, so it doesn't matter the orientation of your triangle, you have to be able to identify your opposite and hypotenuse based on your reference angle. So here I can calculate a ratio of the opposite over the hypotenuse, and that's going to be 4/6. And that's a fraction, and some fractions are not going to be giving you nice numbers, but you're going to have to calculate the decimal anyway. So here the decimal for 4 divided by 6 is going to be the repeating decimal 0.667. So it's going to equal 0.667. So that's, well, you can say repeating 6. Okay. The next triangle, here I have L marked as the reference angle. Okay. 8 is the side right beside this reference angle. Let's call that the adjacent side. And 9 is all the way opposite of the reference angle.
With the following teachers, please contact the main office. Mr. Carabine, Ms. Figueres, Mr. Mora, and Mr. Ticino.
Okay, so the ratio we're going to write here, which of the 3 ratios is appropriate? It's going to be the opposite over the adjacent side. Opposite over the adjacent. Not the adjacent over the opposite. It has to be opposite first on top divided by the adjacent on the bottom. So 9/8. And we're going to round that answer. So we're going to convert that to decimals too. So 9 divided by 8 is 1.125. So we'll keep it to 3 decimals. For the next one, even if the angles get much narrower, look at the reference angle here, it's marked as angle X, okay? The 11.5, you still have to recognize that that is across from the 90-degree angle, so 11.5 is my hypotenuse. The 3.2 is all the way across from the reference angle, so that's going to be the opposite side. Okay, and the ratio relating the opposite and hypotenuse is going to be the opposite on top and the hypotenuse on the bottom. So let's write that down. Opposite over hypotenuse. And now some of our numbers here are already given as decimals, so we're going to write a fraction with decimals in it, which is okay. 3.2 divided by 11.5. And then you take a calculator and you calculate the answer. So here I'm going to just take my calculator, 3.2 divided by 11.5, and we get 0.278. 0.278. And again, we're rounding to 3 decimals. Okay, so again, the ratios, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent are the 3 ratios. And these ratios have names, okay? The opposite over hypotenuse, that's called the sine ratio, S-I-N-E. It compares the opposite and the hypotenuse lengths, okay? So in our calculators, the sine ratio is denoted by this label, S-I-N. It's not sin, it's pronounced sine. Theta is our reference angle, right? That's a Greek letter. It's a Greek letter, theta, and that denotes our reference angle. and the ratio is the opposite side divided by the hypotenuse side. Okay, so if theta is a reference angle in this triangle here in this diagram, then we have to label opposite hypotenuse, and this side is the adjacent side. Okay. The second ratio, the adjacent side over the hypotenuse side, has also a name called the cosine ratio. We label that the cosine ratio. So every time I say sine ratio, I'm referring to the opposite over hypotenuse. Whenever I'm saying cosine ratio, I'm referring to adjacent over hypotenuse. And so that's adjacent over hypotenuse. And on your calculators, you're going to have a button that says cos, that stands for the cosine. Okay, theta again is your reference angle. And the third ratio, the opposite divided by the adjacent side lengths, is called the tangent ratio. And on your calculators, you'll have a button called tan with a theta in it, and that just relates the opposite side over the adjacent side. Okay, and so there's an acronym we use to remember the ratios. It is called SOHCAHTOA. The first letter in each of these, S, C, and T, stands for sine, cosine, and tangent. Okay, so, and the sine of the angle is always going to be the opposite over hypotenuse. So the next two letters refer to the ratio, opposite over hypotenuse. So the sine of the angle is opposite. The opposite length, remember these are lengths, over the hypotenuse length. The cosine ratio is, looking at the mnemonic here, ka, so ka, adjacent over hypotenuse. So the adjacent over the hypotenuse. And then toa, tangent, is the opposite over the adjacent. So opposite over the adjacent. Okay, so now we have named our three ratios. We can use our calculator to find the value of our trig ratios. Okay, and I'm going to show you on my screen here. Let me see if I can shrink my screen a little bit and get my calculator out. Let's put it into scientific mode. Okay, and let's shrink that a little bit. Okay, perfect. Oops, I want to overlay it a little bit here. Okay, so if I'm going to do this on a calculator, now we're going to be working with angle measurements. So if we're given the angle of 53 degrees, we can calculate that on our calculator. Let's clear our screen. Make sure your calculator is in degree mode. So my calculator is in degree mode. You should get the same answer as I do when I hit sine 53. And you hit equals, and you get your ratio. Okay? So sine of 53 on the calculator is 0.7986. I'm going to just take 4 decimal places for this one. If I were to calculate the ratio, right, sine of 53, let's label our triangle. 5 is the longest side, that's our hypotenuse. 4 is the opposite side, because it's across from this reference angle, okay? And 3 is my adjacent side, okay? So opposite over hypotenuse is the ratio for sine, and that's going to be 4 over 5. And that's equal to 0.8. So you can see they're pretty much identical answers. If I round to 0.7986, I get 0.8. I can do the same thing for cosine 53. Hit cosine 53 on the calculator. Cosine of 53. And we get 0.6018. And the ratio is the adjacent side over the hypotenuse, 3 over 5, and that's equal to 0.6, which is pretty identical to what the calculator gives you. And the tangent of 53, same thing. Look for the tangent button on your calculator and enter 53. On some calculators, you might enter the angle first and then press tangent, if you're not getting the same answer as I am. Okay, but you should be getting 1.327. And the tangent is the opposite side ratio, which is 4, divided by the adjacent side, which is 3. And that's going to be pretty much the identical answer, 1.33 repeating. So practice using your scientific calculator to calculate the trig ratios, okay? Right, sine of 40, you could do that. Sine of 40 is 0.642. Cosine of 40 is equal to 0.766. And then the tangent of 40 is equal to 0.839. Okay, so 3 decimals is good enough. You can do the same thing over here. Sine of 50, 0.766. Cosine of 50, 0.642. And then tangent of 50 is 1.192. And you might notice something. I'm getting these same answers. The sine of 40 and the cosine of 50 are the same. And the cosine of 40 and the sine of 50 are the same. Why is that? It's because on a right angle triangle, all 3 angles have to add up to 180 degrees. You have a 90-degree angle here. If you have a 40-degree angle down here, then this angle will be 50 degrees, right? And remember, for a 40-degree angle, the sine ratio is this side over this side. And if you get 0.642, okay, then you do the cosine of 50 degrees. The cosine is the adjacent side of 50 degrees over the hypotenuse, which is the same 2 sides as the sine of 40. So you do get the same answer. And you can use the same argument for cosine of 40 and the sine of 50. Okay. So depending on your calculator, you might want to fill out this chart, right? How do I use my calculator to measure oh, I'm gonna, actually, maybe I should do this separately. No, we can do it now. Okay. Find the measure of an unknown angle using the sine ratio. Oh, let's call it actually unknown side. Okay. Let's make my screen big again. Find the measure of an unknown side using the sine ratio. Okay, so how do we use our trigonometry, sine, cosine, and tangent, to solve some problems? Okay, well, I can write the sine ratio as the sine of 41 degrees, right? That's going to be a reference angle. And remember, the sine ratio is opposite over hypotenuse. So x here is the opposite side, and the 15 centimeters is the hypotenuse. So I can write this as x over 15. So I can use trigonometry now to help me find the unknown side. Right? Pythagorean theorem doesn't help me because I don't know what's down here. There's nothing given. So I only have the hypotenuse, but I have to find x. And I can do that if I'm given the angle and use trigonometry. Okay? So the way this works is if I kind of cross multiply here, I bring the 15 up to the left, I can write this as 15 times sine of 41 degrees. And that's going to give me x. Okay? So it's like cross multiplying. If I divide it by 1 on this side, right? It's cross multiplying like that. But you don't have to do those extra steps. Just multiply. You can say multiply both sides by 15. essentially. Okay, and then if I go to my calculator, I can input that 15 times sine of 41, and I'll get my answer, 9.84. So x equals 9.84. And you just want to make sure you check your answer. It makes sense. It is smaller than the longest side, smaller than the hypotenuse. So I can be pretty assured of that. The only other mistake you might make is maybe not making sure your calculator is in degree mode, because angles are in degrees. There are other different angles in mathematics, like radians, but we're not going to study that in this course. Just make sure you know how to put everything in degrees. Okay. Now, it might be a good idea to write down what you're doing for your calculator keys in case you have a different calculator. Okay. For mine, I'm entering 15 times sine of 41, and then equals, and you get your answer. Okay, and some calculators you might have to do the sine ratio first, 41, then press sine, and then multiply that answer by 15. Okay, so see me if you have difficulty with your calculator. Okay, let's look at the cosine ratio now. Here I have a reference angle of 25 degrees. 18 was then my adjacent side. X is the hypotenuse. If I express this as a ratio, the cosine of 25 degrees relates the adjacent and hypotenuse. So the adjacent side is 18. The hypotenuse is x. How do I solve for x? Okay. To get rid of x in the denominator, here's where you might have to cross multiply. So let's kind of write cosine 25 as a fraction. And we're going to cross multiply. Okay. So here you're going to have x cosine 25 equals 18. So it's just an extra step when x is in the bottom. Okay. And now if I divide both sides by cosine 25, I can isolate for x, right? Cosines cancel. Here I have x equals 18 over cosine 25. And I can take a calculator and do that here. 18 divided by cosine 25. And that answer is 19.86. Okay. We're going to look at the tangent ratio now. Here, this time, our reference angle is up here, 49 degrees. And 12 is the adjacent to that 49 degrees. And x here is the opposite to that 49 degrees. And so the ratio that relates opposite and adjacent is the tangent ratio. And I can write that as tangent of 49 degrees equals the opposite, which is x, divided by the adjacent, which is 12. And so it's nice that the x is on top because it makes it simpler for us to get the answer. So kind of half cross multiply here. 12 comes over to the left side. 12 and becomes multiplication, right? 12 times tan 49 equals x. So remember, that's the multiplication between the 12 and the tangent ratio. And if you take your calculator and we do 12 times tangent of 49, we get our answer. Whoops, let's do that correctly. 12 times tangent. We get 13.8. Just double check I did the list side correctly too. Yeah, that's fine. Okay. 13.8. And don't forget your units, centimeters. I forgot my units for the other examples. Let's put them in now. Centimeters and centimeters. Okay. Now, how do we calculate unknown angles, right? So if we're given two known sides and we're asked to find the angle. So we're going to use the sine ratio for the first one because the reference angle is called theta. 27 is opposite to that reference angle, and 40 is the longest side, the hypotenuse, across from the 90-degree angle, right? So I can write this as sine theta equals the opposite side, 27, divided by 40, which is the hypotenuse, okay? And if I'm finding the angle, we have to use something called the inverse sine ratio, and it looks like this. You're going to write here theta equals the inverse, it's like a -1. It's not an exponent, it's just called the inverse. Sine with -1, it's called the inverse. I'm going to create some brackets and put that ratio in there, 27 over 40, just like that, okay? So how did I go from here to here? Well, in mathematics, if I take the inverse of something, it kind of cancels itself out, right? The inverse sine of sine theta just cancels out and just gives me theta. And that's what gives me the theta here on the left side, okay? And if I'm going to take the inverse of the left side of the equation, I have to also take the inverse of the right side of the equation, right? So on the right side, I have inverse sine of 27 over 40. It's like balancing an equation, okay? So you start off with sine theta equals 27 over 40. If you apply the inverse to both sides, it simplifies to just theta, and the right side I have sine inverse 27 over 40. And the answer to that, if I take my calculator, so the inverse can be found by going to either your shift key or your second key. In my case, the second key is the button I'm looking for, second, and the sine inverse appears. And I write my ratio 27 over 40. Close the bracket, use brackets, make sure the complete fraction's inside that bracket. And then you get your answer. So theta is about 42 degrees, okay? So remember, it's going to be second or shift, and then it's sine bracket 27 over 40, and then one more button to close the bracket, okay? You can apply the same idea for the cosine ratio, right? Here's the reference angle theta, 27 is my adjacent side, 40 is the hypotenuse. So theta, so that's the cosine ratio, always start off with cosine. So cosine theta, you always have to put theta, that's your angle, equals the ratio, the fraction is 27 over 40, okay? And if I want theta, I have to take the inverse cosine. So cosine with a -1, and that's not an exponent again, that's just a label, okay, to show that this is the inverse cosine, okay? And in some textbooks, you might see the word arc cosine and arc sine. That's the same thing, that's the inverse, okay? But we don't use that here, we just use cosine inverse and sine inverse with a -1. And again, taking our calculator, oops. Just want to find my calculator. Okay, if I do the cosine inverse of 27 over 40, we get our answer, 47 degrees. Let's round that to 48. The tangent ratio, similarly, here's theta, here's a reference angle, and tangent of theta is the opposite side, so 12 here is our opposite side, 9 is our adjacent side, and the opposite over the adjacent is the TOA here, opposite over the adjacent, that's our ratio. So make sure you put it in the correct order. Opposite comes first, which is 12, and 9 is the adjacent, which goes on the bottom. Okay, as long as you're identifying the correct sides. Remember, opposite is again across from the reference angle, and the adjacent is the side touching the reference angle. So theta, if I want the angle, again, I'm going to use the inverse. If you want the angle, use the inverse. 12 over 9. Tangent inverse of 12 over 9. And that's going to be 53.1. So 53.1 degrees. I'll just round it to 53 degrees. Okay. So those are examples on how you can calculate the ratios. What I'm going to do is in a separate video, I'll put the answers to these examples and problems in a separate video. Okay. So what you should do is try these first on your own and then check with the answer I'm going to post. Okay, that's it.